can start with a basic introduction of our, with name, affiliation, and one or two words about ourselves. And first, I will start with myself. I am NS Prasad. I have been in the renewable energy sector for the last 35 years with my first job in ABB in solar water heating. Then after that, I moved to wind sector in 1995, and I also currently I'm working partly on wind and partly on solar. And as an engineer, I have graduated from IIT, and currently that is my short background without going to my wind sector in 1995. Now I request Rakesh ji to introduce himself.
Myself, Rakesh Agarwal. I'm as a background, I am an electronics and sound engineer with my entire life devoted to broadcasting, where I have actually 6 patents in my name for introducing a new communication technology which opens spectrum capability by 5 million times. And at the same time, I had this idea of designing a wind turbine where we can use drag as a major force and get rid of reverse drag in the half cycle, which my logical control brain did help me work out. And I have a patent on this wind turbine also, which can generate 5 to 10 times more energy per square meter of wind in the actual practice. So far, I have only evaluated in the small wind tunnel with a single panel that yes, reverse drag can be converted into lift, and that I had succeeded. And now
Rakesh ji,
yeah,
we will go into technology details a bit later, 1 minute, 1 or 2 minutes later.
Okay.
This is just a basic introduction.
This is my small background, and I am the chairman of Comcon Group of Companies, where
Right.
I have established, and I am practically now into R&D only, and actual business I have retired.
Right, thanks. And then now I would like to request Kumar Will to introduce himself, because I'm just going with the left to right. That's the only order. Otherwise, there is no order.
Okay. Thank you, sir. Thank you for inviting me for this nice session. And before I start introducing myself, I wish all the best for WWEC and Terry for organizing such a wonderful event and bringing all the like-minded peoples together to discuss about renewables and then brainstorm and then address to the need of the hour, which is making the earth green. So thanks for being a part of this program. So about me, I'm Kumaravel, a mechanical engineer, and then did my master's in business administration and my PhD in energy economics, combining wind and solar. How to combine these two energies in a better form in a techno-economical manner. That was my PhD all about. So coming to career, I was now 22-year-old in wind industry. I was working with Prasad sir at Nive. Prasad sir and me, we were all one of the initial people who started Nive, which is now Nive. Those days it was CWET. Now it is called as Nive National Institute of Wind Energy. So we were working together along with the Danes to bring in the technology of design, testing and certification of wind turbines to the country. So after spending a decade in Nive, then I moved to industry. Then I joined Regen Powertech, which is a wind turbine manufacturing company. So I was taking care of the technology transfer from Germany, from Vensis, which is the design company. So bringing the technology from Vensis and then making it to the shop floor, and then also taking the turbine to the field, and then working on prototype testing and certification aspects of it. So that is all about what I did at Regen Powertech until 2018. And after 2018, I joined Deutsche Windgard, which is a wind energy consulting firm. Hope many of you know that. So it is a German company, 20-year-old German wind energy consulting firm, which started 3 years back their Indian operations in India, and I'm heading that as its managing director. So Deutsche Windgard is into testing, certification, wind resource assessments, and then offshore related design consulting. And then we also do a lot in wind tunnel engineering, testing airfoils, new blade airfoils. So also we simulate the logistics of an offshore environment. Before taking the long blades and towers into the sea, we can also do a simulation in our wind tunnel, what kind of turbulences that would occur and what kind of preventive measures needs to be taken up. So this we can do in our large scale wind tunnel. So this is all what we do in WindGuard shortly. And then I think I will stop here and then we can go ahead. Thank you, sir.
Thanks, Kumar Well.
Thank you, sir.
I now request Daniel Allington referred by SDI to us. Please introduce yourself, Daniel Allington.
Hi, thank you very much for that. And thanks for inviting me to speak today. It's a great honour. So again, my name is Daniel Allington. I work for the Offshore Renewable Energy Catapult, which is a British institution. I guess a little bit of background on me. I started in oil and gas and working with a lot of subsea kind of interfaces, ROVs, pig launchers, and doing a lot with FPSOs. So the kind of the connection with the cables and the hoses up through the bent stiffeners onto the floating oil rigs. This technology is kind of being used now with the floating offshore sector, which is really gaining some speed. Some really good innovation coming out of there. Been in the industry for about 7 years now, so not as much as some of the esteemed colleagues on this call. Still quite a young pup. But yeah, I've got some notes on the company during my presentation, so I'll just leave it there. So thank you very much.
Okay, thank you. Can we go ahead? You are through with the introduction. Hello, Daniel. Hello.
Pardon?
You are through with the introduction?
Yes, I'm through. Yeah.
Okay.
Nice and
Right.
short. I'll keep the just saying I'll keep the information on the company for the presentation. So I'm not speaking twice.
Now we will go to our actual technology discussion. And first I invite in this list, there is an order. There is no special order which you have created here. And the person who has come first, we have put like that. So Kumar, now I invite Mr. Kumar Well to representing Dutch WindGuard, the company. And you have heard his introduction a few minutes back. Now I ask him to make his presentation. The title of his presentation is, what are the main developments and the trends in wind technology? So trends in wind technology is very interesting to know because they have been going on and on every. Of course, we know the mobile way of enhancement of the technology. I think wind is also catching up with that speed. With this word, I will leave the mic to Kumar Well to make his presentation.
Sure, sir. Yeah. Thank you, sir. Can I share my screen, sir, and then start the presentation?
Yeah.
Okay, sir. Yeah. So do we have any time limitation, sir, for the presentation?
Okay. Yes. Now, no, let me just do that because now we are 3 here, right? And
Yeah.
what is the current time now? We are at 3 o'clock and we have time up to 4 p.m. We have 1 hour.
Okay.
So each one of you take 15 minutes to 20 minutes.
Okay, sir.
Each
Okay.
one of
Thank
you take 15 to 20 minutes for your presentation.
Yeah.
And before we start this session, I wanted to also thank SDI, Scottish Development International,
Yeah.
for supporting this event.
It's visible, right?
Yes, sir.
Okay. Yeah. So once again, good afternoon, everyone. So I have framed the title like this as research opportunities in wind energy. So, so our main objective is to convert the non-conventional energies, wind and solar, into a conventional form through possible research and innovation. So that is the theme here. I think about WindGuard, I have explained what we are doing, so I will not spend much time. So we are into all gamut of we are into a gamut of a lot of wind energy services. Like I explained, we are into measurement, certification, wind tunnel engineering, turbine inspection, site assessments, consulting, simulations of load flows, and all that. Okay, so I will start with the offshore. We all know we are doing a lot in the offshore field. India is also trying to get into the offshore environment by having its first pilot projects in the coming years. Maybe in a couple of months or maybe in the next year, we are so aggressive to have the first pilot projects. So Nive and everybody is working on it. So what my thinking here to the audience here is we should start working on many possible research in the field of offshore, whether it is coming out with a new design of foundations or new type of towers or any possible research that might develop the offshore wind energy. People should start working on. That is the intention of the slide here. We have different type of foundations, like we have monopiles, we have jacket type, we have floating structures. So many of them are in existence and in operation. So of course, a lot of it needs optimization in terms of price reduction. So scientists and engineers like us need to work on it more and more to optimize it. So therefore, more innovations need to come in this area. That is my submissions here. Yeah, and we should also work in areas like improving the aerodynamic efficiency of the blades and also reducing the aerodynamic loads. Wherein today we try to do the whole pitching of the whole blade, the whole even in India, if you take it is 70-80 meters of blade length today. Average blade length of Indian wind turbine is close to 60 to 65 meters now. So the longest blade made in India is 78 meters, if I'm right. So such a long blade, pitching it from the root is a huge load to the pitch mechanism here to pitch in and pitch out. So therefore, people are working on doing what is happening in the aircraft. So just pitching in and out of the trailing edge of the airfoil, not the whole airfoil is getting pitched in and pitched out. So the change in angle of attack happens only at the trailing portion of the airfoil. So this is something which people are trying to borrow from the aircraft industry to wind industry. So research is happening in this regard. If this comes in, then we will save a lot in terms of reducing the aerodynamic loads. And people are working on split blade concepts, splitting the blades in order to make the transportation much easier. And again, challenges are there, how to connect these split blades back into the original form in a harsh environment, in a remote site. So there different type of technologies are being thought about. One is having some metal part connection, or people are also working on FRP to FRP part connections. So different connections are being discussed and evaluated experimentally and also practically. So I invite more research and innovation in this regard, so that the better logistics can be achieved in transportation of such a longer blades, especially in countries like India, where we work on complex terrains, especially in Maharashtra and Karnataka. There are many complex sites, semi and high complex sites. So their transportation becomes very difficult. So if it is a part of the blade we have to transport like this, it becomes easier. And there is another area where many research is happening, which is the usage of the concept from of cryogenics. So trying to build high temperature superconductivity generators. Superconductivity generators helps to reduce the size of the generators. Today we talk about 13 megawatt and 15 megawatt, up to 15 megawatt we have gone in the offshore. Companies like Vestas, GE, and Chinese companies like Mingyong and Goldwind, they all now they're having the pilot demonstration for up to 12 to 15 megawatt size capacities. So for such turbines, handling such a big generator is difficult. It's a very difficult task, and it's very heavy to lift it and assemble it. So therefore, we should bring in the concept from of the superconductivity, where even a 10 megawatt size generator can be as small as possible, like a 2 megawatt generator, by applying the cryogenic concepts. So this will help to reduce the weight. Just to give you an indication here, if we use this, we can reduce a lot of tonnage. And just to give an idea, a 8 megawatt turbine, a gearless machine will have a weight of 480 tons at the top. So you can imagine such a huge weight, and in order to accommodate such a huge overhead mass, what will be the weight of the tower, and then thereby the foundation, you can easily imagine. So everything is cost. So therefore, in order to reduce the cost, we need to reduce the weight, and one way to reduce the weight is to reduce the size of the generator. So that is one thing. And there is also a concept called sway concept, where we are trying to have a larger diameter of the generator. You see, this spokes wheel is basically the generator. So this has multiple number of poles. Even in the existing synchronous machines, where we have multiple asynchronous machine or induction machine has 4 or 6 poles, we all know. And synchronous type machines with permanent magnets or electrical coils will have like 80 or 90 poles. So this is an expanded concept, or a larger version of such generator, where you have more number of poles, like 200 poles or 300 poles housed in such a large diameter. So this will help to have more power with lesser rotation, because you have more number of poles. 120 F by P, we try to play with the parameter P. Number of poles we try to increase, and then harvest more power. So a Norwegian design is being worked out. I don't know what is the current situation, but this is a few months or an year back. I happened to visualize this technology. And also there is a concept called wind drive. This technology started in a way, and then it stopped somewhere. But it is an interesting technology, which is nothing but, we all know wind is a intermittent source of energy. Wind has a lot of fluctuations. So all the time a wind turbine cannot give a constant power, because wind is fluctuating, and thereby the speed of the blade will also have a variability. And then, but whereas our generator needs a constant speed, like 1500 RPM, for which it becomes gets into the synchronous mode. And how to achieve that is using this hydrodynamic coupling, which is called as variable speed hydrodynamic gearbox. So this is a company in Germany called Wind Drive, originally owned by a company called Voith, VOITH. Everybody knows that. They're a big brand in Germany. So they started developing this. And to my knowledge, they also tried in one machine, which is called a technology called D-Wind, in a 2 megawatt machine. But after that, it has not picked up. So I would like to have more research and innovations happening in this regard. So currently what we do is, electrically and electronically, we have this power converters which try to bridge this gap. This intermittency of power from the wind is bridged and then fed as a constant power to the grid with the help of this frequency converters or full scale power converters. So from mechanical side, we can also address this topic with the help of this kind of wind drive. So more research can happen, and I'm sure somebody is working, and we should also enhance more from our country as well. It is the same explanations about the wind drive. And we should also work on concepts like Magnen, trying to harvest power at a very great height of 300, 400 meters using the concepts of Magnen, which is called MARS, Magnen Air Rotor System. And so this is a helium-based balloon, which also has a rotor-like structures on the periphery, which starts rotating because of the wind blow. And there is a generator inside, and which produces power. And there is this electrical cable acts as a winch for the whole system. And then rest is all the transmissions, we know that. So this kind of system is also now coming up. And this is highly suitable for offshore refineries and many of the offshore applications where we need a standalone power. So this is one good system for it. And a similar concept is KiteGen. This also is a method to harvest winds at a very great heights of 300, 400 meters, where it is more laminar and no turbulence is visualized or experienced by the rotors. But here we are trying to harvest the tension of the string, not trying to produce rotational energy and produce energy, electrical energy. This is trying to harvest the tension of the string, and there at the bottom of the string on the ground we have this linear generators, so which produces the EMF. So, and then we can also go for building integrated systems, and few demonstrations have already happened. Like this is a actual picture from World Trade Center in Bahrain, where between two strong high-rise buildings they constructed this kind of arrow bridge and then started placing a 250 kilowatt wind turbine. Of course, here there is no yawing involved in it, but if it is a coastal side and wind keeps coming from all the time from one direction, then this is a wonderful system. And of course, the building also should be capable of withstanding the vibrations and dynamics that will come from the centrifugal forces. So that is something the designer of the building has to consider it. And we can also go in for bringing more and more advanced vertical axis wind turbines, like one of the panel members is talking about the drag utilizing drag energy for converting for producing the power. So this is also one application. Vertical axis windmills uses the drag force of the wind. So more advancements can happen in this area. And bringing in maglev. So this is a vertical axis machine, typically vertical axis wind turbine with multiple blades. But at the bottom of this, we try to use a magnetic levitation principle, which reduces friction and enables more fast rotation. So nothing but trying to borrow the magnetic levitation concept, which is applied for the bullet trains. We're trying to bring in that here and then use it for harvesting more wind power. And this is one concept which I picked up from the secondary sources, which is definitely an interesting one. Again, trying to bridge the variability of wind to a constant power output. So here this machine produces more and more variable compressed air, and that pressurized air is stored in a tank, and then from the pressure tank, we just release it in a regulated manner to an air motor and then subsequently to a generator. So this is one technique where we can in a simple manner produce a constant power from a wind turbine. So yeah, so just to summarize, we can do a lot in the blade aerodynamics area to increase the Betz limit. Betz says 59 is the is the limit beyond which any wind turbine blade cannot produce power. But practically, I as a measurement engineer have seen only 45 to 49% maximum a blade has achieved. Any blade in the industry has achieved up to maximum of 49, not more than that. So there is a lot more to improvise in the blade aerodynamics. So better airfoils has to come in, especially rugged airfoils. Today in India, we also face problems related to dust deposition or soiling, we call it. Because of that, especially in the northwest part of India, in the Gujarat-Rajasthan belt, due to the black cotton soil and the dry and arid temperatures, this sand gets deposited on the leading edge of the blade, and because of that, the aerodynamic efficiency drops. And this is also connected with the airfoil design. If it is a thin airfoil, it is more susceptible and more vulnerable to this kind of dust deposition. So we should have a strong, thick airfoil, efficient airfoils to withstand to this harsh environment and also produce better efficiencies. And of course, thick airfoils also results in heavier mass. Heavier mass is heavy cost. So we should try to strike a balance between that. And so we should also work on blade materials, replacement of composites, because today we also face problems related to how to dispose these composites. Today, many turbines in the world have crossed 25 years or 30 years. So now we started facing the problems related to destroying these composites or how to reuse it. So many companies have come with innovative ideas of using that for making cements or making roads or making a different kind of plastic for some other application. So we should enhance those research and innovation in that perspective. And yeah, disposal of blades and split technology we discussed. And we should also try to electronically, we should try to bring in more advanced control systems to reduce loads and then improve fatigue life by concepts called independent pitching and thrust clipping and torque control. These are different strategies or algorithms that can be built on the turbine controller to reduce loads and improve the fatigue life of the components. And also we should try to bring in more the IT engineers or the mechanical engineers can work on better aeroelastic codes for simulations and validation of the loads, which is one of the very difficult tasks. When someone wants to design a turbine, the first and foremost task is to simulate the loads, where we have some industry tools currently, but it's all costlier, and also there are some uncertainties always built in it. So better load simulation tools are always welcome. So people should also research more on that. And different type of towers, we can always work on hybrid concepts like steel tubular mixed with a lattice tower, or a tubular steel along with a concrete tower, or going in for a full timber tower, wooden material. So we can also work on that. And airborne systems definitely attract more research and innovation, and different generator concepts with better efficiencies is a need of the hour. And we can also bring in more modeling techniques in the field of WRA, energy yield assessments and forecasting, which is one of a hot topic today. So many things are happening. So, and we should also further enhance more in this field of forecasting, and utilization of more and more remote sensing devices, LiDAR and SODAR, and using ultrasonic techniques for measuring the wind speeds is definitely a more welcoming one. Of course, on here and there, many research are happening, but we should enhance more. That is what I am telling. And also we can do a lot in SCADA and CMS aspects. SCADA is supervisory control and data acquisition system for managing the whole wind farm. And people are working on many asset management tools to bring more analytics to the whole wind farm. So to diagnose the performance of the whole wind farm, not individual turbine, but the whole wind farm, how to diagnose it, how to analytically compare wind farm to wind farm, and how to compare the performance from period-based comparisons, how to perform period-based comparison. Last year, how was my wind farm performing? What is the performance this year? What is the variation? What is the annual variation? So a lot of technical, analytical thoughts can be built in this kind of tools to manage the whole asset. And condition monitoring is definitely a need of the hour. Today, we are working on very long blades, and we are working on offshore environment, etc., where frequent visit to the wind farm, wind turbine is not possible. Therefore, a strong, robust health monitoring system is needed. So therefore, even sitting in the onshore, sitting in front of a system, you can monitor the health of the turbine, and then you can plan for some preventive maintenance or whatever it is. After you get an alert from red alert from your CMS system, then you can plan your maintenance on time. So that is what the CMS systems can help. And many CMS systems are being designed and implemented in the offshore, but also in the onshore turbines, especially with 3 megawatt plus category turbines onshore. We need to monitor the health of the gearbox and the blades and the generators temperatures very closely. So CMS will help in that regard. And foundation design, initially I was talking about innovating more cost-effective foundation designs for the offshore turbines. And we should also work on HVRT and LVRT, high voltage right through and low voltage right through farm level simulations. Today, the grid authorities, the national grids, they're expecting this from the OEMs. They want the simulations to be performed on a broader perspective, on a broad level, on the larger grid, to see how this wind farm is creating a kind of imbalance or a plus or minus, whatever it creates on the grid needs to be simulated and then captured. And this data has to be submitted to the utilities, and better simulation tools can be researched or designed. And we should also work on hybrid power systems, bringing the hybrid, bringing wind and solar and other forms of energy together, and then combining them with the energy storage technique, so that we give a constant power compared to a conventional power plant. And many research is also happening in that regard. And recently I have also come across a a technology of called graphite thermal energy storage, which is very cost effective compared to a lithium ion or any other storage technique. Graphite can store large amount of heat, and it is just easy to make graphite bricks, and then just convert the electricity into heat, and then it stores heat for a longer time, and then you can convert this heat back into steam or electricity based on your needs. So therefore, I'm sure this kind of techniques are much available, and we should explore that. And yeah, and then finally, we should also bring in more operational safety. This is related to safety, something I wanted to put here to the forum. Many safety aspects to be brought, especially to the offshore turbines when people go inside. What kind of safety mechanisms the turbine itself have, and then what the people should take care of, what kind of safety measures that needs to be taken care. That is also an area where people should work and are working to some extent. Yeah. So with this, I will stop my discussion talk here, and then I would like to listen from the other panelists here, and then address to the questions from the audience. Thank you.
David, coming back. Yes. Yes, yes, sir. Just give me 1 sec. I will call you after some time. Then I'm moderating another session. Right. Okay. Yeah. Hello. Marvin.
Sir.
It's an excellent presentation what you have done, taking us through the entire range of development that is happening,
Yes, sir.
including the new storage methods.
Yeah.
And I would like to request either the audience or the other panelists who are sitting there, if they have any questions regarding 1 or 2 questions regarding this.
I've got a quick question, if that's okay.
Yes, yeah, please.
Yes, please.
Regarding the sorry, the superconductor type technology to reduce size of the turbines, I know that if we are to start creating lots more wind energy, we're going to start needing a lot more material, rare earth material for the generators. I don't have that much experience in the superconductors, but does that use kind of the similar kind of materials, or are you also looking at or heard about kind of non rare earth material generators? So that's something that we've been toying with for a little bit now.
Okay. Yeah. Thanks, Daniel. Thanks for the question. Like you, I am also not a strong expert in the superconductivity theory. This is for the panel, and then just to enhance the knowledge here for the audience, I have captured that. But I can give you a hint that AMSC Windtech, which is an Austrian company, American Superconductivity and Windtech. So these two companies, they have a joint venture. They're Austrian-based company. They're working on this concept. So we can maybe later on connect to them and then get some more insights on this.
Thank you.
Yeah. Thanks, Daniel.
Hello. Any other questions, please? Rakeshji? Or any other question from the audience?
Okay, I guess I've got one more. That's okay. If no one else is going to ask some really interesting points there. On your blade work,
yeah,
I know you're looking at a lot of the stuff on kind of the aerodynamic and all that kind of stuff in the blades that can be put together offshore or kind of at site.
Yeah.
Are you doing any kind of work with the corrosion type leading edge technology? Because I know that once we start going offshore, the conditions are going to be a lot different. I know India's got a lot of onshore turbines, but once you make the move to offshore, is it kind of coating technologies that are going to be kind of trialed and ready for that kind of industry? Or is that something that it needs to be worked on? Or if you know
Definitely.
not?
No, definitely. It is definitely important to have different coating solutions on the blades and the towers, especially when it is taken to the offshore. We need to have coating solutions, and I think a good amount of development has already happened. And today we have many gigawatts of turbines operating offshore, especially in the North Sea in Europe. So
Yeah.
they're well maintained. Yeah. So many techniques are.
The only concern I've got is the kind of the conditions in kind of around the UK and Europe. It's going to be quite a bit different around
Yeah.
kind of India and further south and kind of east in Asia. Obviously the weather patterns and all that kind of stuff's quite a bit different. So and harsher, I would say. So I
Yeah.
think it's a really good kind of interest to commercializing the offshore turbines, because the less time you can send people offshore to either inspect or to recoat, the better.
Yeah. No, you're sure. You are right. You are right. When we go for the pilot projects in India, we will have some burning of fingers. We will see this corrosion effects coming in. So then more research will start happening of how to prevent this. So better, stronger coating solutions are needed for the harsh and salty corrosive environment of the Indian coast. Yeah.
Yeah. Thank you. Again.
Thanks. Any other questions from the audience?
Yeah. Now what we can do, we can request Mr. Daniel sitting next to you to give his presentation now.
Okay.
Daniel, though we thought we can have 20 minutes, now it's already 3:25. Please limit it to 15 minutes.
Will do. That's absolutely no problem with me.
Yeah.
Select that one.
Is it okay if I call you Daniel?
Of course, yes, please.
Right.
I've been called a lot worse in the past.
Sir, please click on duplicate screen, sir. Yeah, sir. Your reverse window is there.
Pardon?
Yes, sir, please click on display setting and reverse your window.
Okay, you are giving
Setting
me.
reverse.
Daniel,
Please
please
click
listen
on display setting, sir.
Yeah, it is. We are able to see.
Which are you seeing the presentation mode? Are you seeing
Yes, sir,
the
I see presentation mode, sir.
presentation mode? So that's fine.
Reverse your window, sir.
Okay. Reverse the windows.
I think, sir, please stop your sharing and please remove presenter view. Sir.
Yeah. Try that again. To share. Okay. Sorry about that.
It's fine, sir. Please go ahead.
That's right. Okay. Thank you.
Excellent.
Is everyone happy? Yeah. Lovely. Okay. So again, thanks for the opportunity to speak today. I'm going to be going through some of our innovation and validation type techniques that we're doing from the Offshore Renewable Energy Catapult. Kind of some of the agendas we're going to go through, kind of the background and market growth. That's typically around the UK, and kind of you can see where the stories came from where we started to where we are now. A quick introduction on Catapult, our research infrastructure, and the O&M technologies that we're kind of currently supporting and innovating. So this slide, it just kind of captures what kind of targets that we're aiming for around the UK. and kind of who the developers are and what they're kind of forecasting for the next couple of years. And you can see by the first graph in development that there's quite a bit going on. That'll take you into the 30-40 gigs by hopefully 2030. This graph down here, you can see where we kind of are last year and at the moment, kind of on track. But if we want to achieve the targets for net zero, the graph goes a lot steeper. So we think that's going to come from the bigger turbines and accessing offshore wind, floating offshore wind opportunities. And that will open up a lot more of the windier bits of our sea. So that's where we'll get the best electricity. And then hopefully by 2050, we're targeting 75 gigawatts of the UK wind supply, which is a really ambitious target, but I believe it's something that we should very much strive for. The catapult is kind of broken down into 3 areas. We have test and validation, so that's new generation turbines and balance of plant. They are kind of currently testing GE's Haliade-X, the 40 megawatt turbine, and we've also got LM's 107 meter blade in our test facility as well. That's this one here. So we're running a number of tests to validate the design parameters, and we've already successfully tested 1 blade. We've got the 2nd blade doing the 2nd host of tests at the moment. Operational performance is another stream, and they're the kind of guys who are close to the owner operators, looking for the next kind of high TRL level systems that can help with operation and maintenance, kind of solving the developers' problems that they have. So if they need a AUV or a ROV to be out at the turbines full time to charge, then guys will kind of sort out the market and get an underwater kind of ROV that doesn't need a surface that can charge subsea. That's just for one kind of instance, but they're kind of problem solvers at the kind of high TRL level. Excuse me. The stream that I work mostly for is the research and disruptive innovation team. We take really low TRL and kind of university work all the way through to TRL level 6 or 7. So we work in evaluation support of emerging technologies, floating wind. We also do wave and tidal, and we'll come on to that a bit later. Energy networks and storage, also looking at hydrogen projects. So we're currently trying to get some funding for a converter, electrolyzer, sorry. So we can start looking at ways of storing hydrogen and then converting that into electricity. We also are a gateway to UK academia. We have 3 research hubs around the UK, and they study in drivetrain. One's in blades, and the other is in electrification, pardon me. So in total, there's about 9 universities covering all 3 of them activities. So not only do we help with the low TRL level stuff, we also help the commercialization of the technology for the UK and any other company that comes to us for help. So we actually assess the technology development and see where they may need support. We help bring in other kind of collaborative partners who we know and we understand that are working in the same area, or they have a technology that is also needed for their product. Commercial readiness, so we can offer support in business planning, IP protection, and securing manufacturing supply chain, or kind of setting that up where needed. And we have teams that are excellent in completing reports for market readiness. They can kind of predict what's the next leaps in innovation. Is that going to be I go back to the floating wind again. Are we going to be building these turbines and substructures at port and then tow them out to site? Or are we going to be using the big installation vessels that we've got at the moment just to build them at site, and kind of what's needed for either solution? And again, we work with our test and validation team. So once we've done the design, we've kind of verified it, we can do either full-scale testing or we can do prototype testing to prove out their designs. So the research infrastructure. So this is a bit of a busy picture, but if I can count from number one, we use this as our 1 megawatt test facility. So this is kind of for really low TRL level stuff for people to test on our drivetrain and gearbox and test generator, so they can demonstrate either new lubricants, new bearings, any kind of parts or modular design which can be removed and replaced. Also in number one, we have our 50-meter test facility. I think 50-meter test facility was built in 2008, I believe, and that was kind of to test and validate the blades of the time. Quickly realized that with the developments of offshore wind, the blades are going to get a lot longer. So I might jump around a little bit here, but number 8, just to the right of number 1, that's our new blade test facility. We call it Blade Test 2. And that's the facility that's kind of currently testing LM's 107-meter blade, which just about fits in. But now what we're looking in the future to larger blades, one's been mentioned at 130 meters and so on and so forth. So maybe some development there for us. I'll just work down the picture. So number 9 is our 15 megawatt test facility. So we're currently testing GE's 40 megawatt Halier X in there. That's been a 4-year program to verify the power outputs and the test design there. And 13, just next to it, that's our A-grid system. So with this system, we can tell the nacelle, we can imitate any power cell on the Earth. So we can tell it that it's been in the UK. We can say that it's the power is coming from India. We can say it's from the USA, because all the power infrastructure is a little bit different. Going down again, number 7, that's our 3 megawatt test facility. This was initially built for the wave industry. It still does get used for that kind of technologies, but we see more testing, more innovation works going on here. Again, a step up from number 1. So this has the ability to implement torque and force on the generator. So that's helpful when developing new types of bearings, developing new types of shaft and all that kind of stuff. You can see 3 docks there. They're all can be emptied and filled with seawater, North Sea, just to the right of the picture. In number 2, there's a simulated dock, simulated seabed there. So we kind of enter. We can fill that seabed with any kind of material that the client would want. So if you're trying to imitate the North Sea bed, that's fine. If you want to imitate the seabed from around the world, we can do that in there. Number 4 is kind of just the same kind of dock, but that's currently carrying out a dynamic cable test in there. Swooping across, number 3, you can't really say there, but we've got a number of rain erosion rigs there that cover the blade kind of research that we do. So we can verify the coatings, we can see what they're doing with kind of salt spray tests that are running 24/7 in really kind of worst case temperatures. Number 6 is our electrical lab. So a lot of work going on there with the testing of cables. We've also got a dynamic test rig in there, which can kind of flex and fatigue the cables over a number of cycles, which we then take away and investigate to see what kind of damage is done to see they've been designed correctly. And I'll kind of combine number 5 there. That's just our training tower, which is a 27-meter tower where we can train technicians to go up and down. So much more saying that. And number 11, which is on the very right-hand side of your page, is our 7 megawatt test turbine, which is up in Edinburgh. Sorry, just past Edinburgh, Leathermouth. So we regularly put different types of kind of monitoring software on there to carry out our condition monitoring and artificial intelligence type packages. And that's where I get most of our data from, because data is very hard to come by in the offshore world. People kind of hold that information, and it's not often regularly shared. And number 10, just below that, that's our MetMast, which is just off this facility. We collect wind data, we collect all different types of information from there, and that also enables us to advise and help people develop their floating LiDAR systems that would be kind of deployed in any kind of future offshore site. So there's a lot to go through there, but what's good about this site is it's all kind of compact and together in one place, and that's off the northeast of England in Blythe, which is quite close to the new Dogger Bank project, which is going to be the largest wind farm in the world. So I'll just talk about the facilities a little bit more. This is our largest test facility, doing some training there. Got some accelerometers on the blade here. The powertrain facilities, obviously we've got the 1 megawatt, which is housed in the 50-meter test facility. We've got the 3, the 15 megawatt powertrain facilities. The electrical lab, I think this is a video, so this is kind of what I was referred to before by the dynamic testing rig. So we can test the cables through a number of different strains and mechanical movements to see what damage is done, or if the design is adequate for that. We do a lot of O&M test and validation, so a lot of research in a blade bug. So this kind of robot goes along the goes along the blade, looking for imperfections, looking for any kind of damage, and that would be used in offshore center. This is just one example of stuff that we do. So this is just at this site in real time. That's what you can see there is the office and then the blade test 2. And this is when the LM blade was arrived at site on the vessel. And as the last speaker said, obviously that blade's hanging off the back of that vessel now. There is a really big push for how we can kind of transport these blades, so it's that segregated blades, so having them in 3 parts. We're also looking to develop a additive manufacturing capability on site. So that's basically 3D printing the blades and other kind of technologies like that to save, because manufacturing the blades and more pieces is also a very hard thing to do. A lot of the work that we do in innovation is through the digitalization. Pardon me. So we get to think about data, its uses in cybersecurity. I think a lot of you may know that a lot of communications that are used all over the globe aren't actually secure. The military has a very few amount of secure links, but the majority of kind of how data is transported is not secure. We do a lot of benchmarking, and we collect a lot of SCADA data for owner-operators. We have a program called Sparta. That's kind of where we collect a number of clients' data and offer that as a package to see what's going on as an overall view of the offshore UK wind farms. I mentioned the Met data before. We do work on vessel performance, technicians. Digital cloning of sites is quite a big hot topic at the moment. Kind of running the software to see what's going to be happening to these turbines within the next 5, 10, 15 years is really kind of key to known how long these wind farms are going to last. Machine learning and artificial intelligence for failure prediction. When you put these turbines offshore, you really want to know when things are going to break before they break. This reduces downtime, and you can rather replace a small part rather than replacing the whole unit. The condition monitoring that we're doing at the moment is kind of based on the drivetrain elements. That's the bearings, the generator, blades, structures, and lubricants. On the blade side again, we're looking at a larger increased rotational speeds at tip. Obviously, with the longer the blades, the faster the tip's going to go, and they're going to start breaking through the sound barrier if we keep on getting larger blades and larger rotational speeds. So then we're going to need some pretty expensive materials if that starts happening. So the greater potential for erosion and repairs, it's kind of my point that I made to the previous speaker about kind of selecting the correct erosion protection for the harsher conditions for down off India and kind of the Asian markets. Implications for inspection and repair approaches. So that's robotics. Can we send a robot out on a drone so no one actually needs to attend site? Kind of the how do you get them there? How do you communicate with them? How do they make the repairs? Future blade technologies, again, coatings, in design and retrofit, atmosphere solutions, blade repair and replace solutions as well. So we've got a quite large team looking at all these kind of areas across the site and working with other kind of industrial partners as well. We're also developing a RAS offshore test site. So a lot of the subsea kind of robotic technologies that are developing at the moment, it's quite hard to fully verify them, even in a dock that we've got at the moment, due to current, due to other kind of anomalies. So we've actually secured a site just off of the EDF wind farm off of Blythe in the northeast of England. So we can now go down, we have a license to send down kind of anything we want, robotic sensoring equipment to go down and carry out activities there, record the results, and then we can verify that. So going on about the RAS site, you've seen this picture before, but we've recently developed kind of a drone test site for launch and recovery of drones from when they go off to do their offshore inspections. The blade inspection capabilities, we've got a RAS workshop, and we've just built a new RAS command and control center over one of the docks. So that's a collaborative space that people can come, work together, and kind of innovate the newest technologies there. We've got the dockside control centers, a pumping system upgrade so we can empty that dock, as I mentioned before. We've also got river access to vessels and things like that. We are also looking at putting in a launch and recovery system for ROVs and AUVs so it can just be sailed out. That's something that we're looking at in the future. This is the kind of the licensing consent that we've got at the moment, which would be number 6 in the picture. We are also now applying for other consenting applications for further out sea because it's not that deep out at the first initial turbines, and we want to be able to do more kind of intrusive demonstrations. So actually we might want to put a pile in the ground and then have someone come in and remove it for the decom market. There's all sorts of different opportunities that we're looking at to do out there. We as a company, we are based on a third kind of funding. So we get a third of our funding from the UK government. A third of our funding comes from UK and international research competitions that we bid for. And the other third comes from commercial projects that we carry out for our customers. Within the European kind of projects, we look at their Eureka. We've been quite successful in applying for Horizon Europe programs and the European Enterprise Network locally, we look at Innovate UK programs, clean technology, smart kind of programs, and there's also BASE offer their internal programs as well, and there's also different other funds that we apply for. Recently, the UK Innovate UK contacted us about a UK-India kind of collaboration. How the UK can offer our expertise in helping India move offshore.
So that
Around at the
is,
time.
we are almost 3:50. That is 15:50 Indian time.
That's the no problem. That's the last slide. So thank you very much.
Please go ahead. You have done? You have done? Completed?
Yes, all done. Thank you.
Okay, great. Now, so we don't have much time for this long discussion. Now, you said you are doing the offshore testing as part of your catapult portfolio. Testing of wind
Yes.
turbines that are meant for offshore. Are there any standards related to that, or what kind of what is the norms you use for that? For the turbines, are the same standards are applicable which are there from IEC for this?
Yeah, I think that it all depends on which part of the turbine that we're testing and verifying. And there are companies that kind of have the standards, the Lloyds and the DNVs of the world. It all depends on the client's requirements. If they want it tested and verified, they would select the verification methods that they want, and that's usually passed down from the owner operator. So they will use their turbines if it's kind of been verified to the DNV or the Lloyd's kind of standard. So it's all dependent on the client.
Sure. Actually, we would like to have a longer discussion with you, but then given the time limit at the moment, I'm just stopping now here. But maybe what I can do, I can take up a call separately with you after this event. If that is,
Yeah, most certainly. I'm happy to speak to anyone after the show.
so since we have your coordinates from SDI, so we'll get in touch with you.
Perfect. Thank you.
But now, okay, I have only 1 minute for anyone to ask any question to Daniel.
Yeah. Daniel, it was a nice presentation and it was impressive to know about your organization. Like Prasad sir was asking, I also have a similar question. This Blade Test Center, is it an accredited test center according to IEC 17025?
Yes, I believe so.
Okay. And about the drivetrain, can we do a gearbox testing as per 16400-4 IEC? IEC 61400-4.
But two, definitely yes. There is obviously there are guys who I can put you in contact with who'll be more than happy to talk through that, a bit more experts than me, but yes, we'll be able to test to any accreditation that you have.
Okay. Super. We'll keep in touch.
Yeah. Thanks, Daniel,
Certainly.
for your nice presentation. We would allow to have more discussion. But then I would request Rakesh Technology to make a presentation on his innovation. As I have talked to him some time back, he had come out with a new technology, or almost a new technology, which is not in the conventional method of running a wind turbine. So we would like to listen to you, sir.
Thank you. Thank you, sir. And I take this opportunity to present my presentation. Is it visible?
No, presentation is not yet visible, but
I have put it on to, so somebody should help.
but can you share it right now as from your system?
It's already on this my screen, but is it not showing on to?
Sir, please click on share sir on WebEx, sir.
Share on where? Display settings. Not showing up anywhere. That is the reason I had been sending requests to you. Now,
Sir, I permit you to present your presentation, sir. Please click on Zoom share screen.
stop video, share.
Another one share. Please click on share and
Yeah,
find out your right window and share. Yes, sir. Please put on slideshow. First, sir.
slideshow from beginning. Is it there now?
Yes, sir. Going on. Please go ahead, sir.
Visible, sir.
Visible?
Yeah.
We are very much
Now
eager to,
I
very much eager to
take this
understand the
opportunity
concept of
to
both
explain.
together.
And so I have shown is a vertical axis turbine in this picture itself, where
Mm.
you can see these 4 blades have been shown, which are partially open. So these are panels of the blades, which are like a plate, but they are built of multiple panels so that they can be moved on their own axis to close or open. So this gives us an opportunity to adjust to the various wind velocities. Now, if you look at these 4 blades from this cross point of view, which is driving the main shaft below, which can have a generator below or anywhere or upstairs, which is, so you see if the angle with respect to this cross, are you able to see my arrow? Is my arrow visible? Oh, hello.
No, we cannot see the arrow.
Mouse arrow is not visible.
No.
Okay, so the first on the right side, on the right side one, the first blade is exactly in line with the cross member, whereas the opposite one is exactly at right angle. So if the wind is flowing from the one on front side from that direction at a right angle through this, then this blade will be fully blocking the air, so the entire drag energy would be applied onto this plane, depending on how much area of the blade is totally is there. So when it starts moving and it reaches the next at the back one, it gets slanted, so that air will slip through it, and it will generate drag as well as lift. So both the energies will be generated, which will again rotate it anti-clockwise. When the panel moves on, and it reaches the other side, which is against the wind, it does not. Wind passes through, seeing it from the side, so it does not generate any reverse drag. But in between these 2 panels, where there is a halfway through, we can angle the blades in such a way that it generates partially generates the lift, which is in sync with the rotation. And similarly, when it moves on ahead, it can reach the other end, where it will suddenly from inward turning to outward turning, it will move on, and it will go back into the whole rotation cycle all the way together. So how I have shown in this drawing is, I have a camshaft here in the center of on the tower, and between the tower and the cross membrane, and that only needs to be adjusted in 360 degrees to adjust the wind direction 360 degrees to change the blades positions, so that there is no heavy movement at all. It is a very simple movement. Or even if this is because shown on the mechanical dimensions, each wind panel could have its own motor to rotate it in clockwise, anti-clockwise, whatever direction is required. So even that movement is not required, and it becomes very light material. So these kinds of panels can be stacked one on top of the other if required for larger panels, larger turbines, or these can be made as big as possible due to technology, and it will generate. So because all of you would be knowing, drag coefficient is up to 2.1, whereas lift coefficient is only 0.4. So this kind of a difference itself will give you an idea how much more energy from the same one square meter of wind air can be generated. However, in the conventional wisdom, where it says that there is only 5.59%, 0.59% of the energy.
So, sorry, sir, I interrupt you. Please change your slide, sir.
Pardon? Oh, sorry. Yes, sorry. So this is the background on the existing turbines, which is showing that 3-blade turbines are upwind converters, and this is all known to you people. Nothing new for you to present. Whereas I must say that drag force and lift force are at right angle to each other in the conventional design, because we are upwind and they are at right angle. So drag force cannot contribute in a conventional design, or lift force cannot contribute in the vertical axis Darius type designs. Whereas in my design, both the ones are combined together. So it makes it go far beyond that 59% limit set by our Betz constant. So it can go to almost 10 times that. So 500 times than the so far decided things. So another advantage in this my design is that it does not need to be stalled, come whatsoever the storms are, because these panels, these small panels, sub panels, they will open up and let the extra wind go away. So there is no need for any of the other high-end stalling, stopping, or whatever you say in the wind terms. We don't need them. So this is a horizontal axis design I have shown in this slide, where I have shown it balanced on both the sides. So the generator is in the center on the tower, and there are two sides. There are four blades. These blades, this is only just for illustration. It could be 6, 8, or any number of blades, and it will all depend on how big or how large turbine setup we are doing, and these can be combined. The biggest advantage is because our force will come from the in this case the panel which is on the top, and the wind is always higher at the top. So that will contribute maximum to the this panel, and when it reaches the bottom, it becomes parallel to the wind. So there is no reverse drag, and in between it will generate the lift force by making them appropriately slant at those angles. So this is all can be done in electronic software, or it can be done in mechanically if somebody prefers to do that. So there is both the options are there in my patent. So it can be done, or any other hydraulic or any other method of doing it there. So now another advantage here we must consider is, because it is the drag based, and we can start generating energy at much lower wind speeds, and can generate energy, full optimum energy for much higher wind speeds. So our target energy for the optimum design can be lowered down to at least 60%, if not 50%. Like 16 miles is the yardstick of existing turbines. 16 miles per hour is the yardstick for optimum output. It can be reduced to 10 miles easily. And so it will generate energy from 10 miles onwards to say 200 miles if it happens. Full energy, and it can generate, so it will give much more return on investment much quicker, because of this larger kilowatt hours generated. So this so these I have tried to sum up them in wording. That wind blows tangentially to main rotor in our process, whereas it blows actually in existing airfoil designs. So it is a complete change of architecture. Main torque is contributed by the drag rather than the lift. But lift also contributes in two ways. One is it removes the reverse drag to 0, and it adds whatever it can add depending on the design up to 30% of the drag. It can add even in that direction. Area swept in Garv systems is much lesser as compared to the existing designs, and ratio of, see, another advantage is that because we are converting drag into the electrical energy, which is, so it will have lesser tumbling effect on the tower as compared to the electricity generated. So this is another advantage, that tower needed would be either much smaller for the same design, or the same tower can carry much more higher outputs. So this is now key operational differences I want to point out. The Garv design blade panel assembly consists of many sub-blade panels as compared to single blade, large blade. So this makes it, gives many advantages in terms of implementation of it, because smaller blades are easy to carry or easy to manufacture and easy to join, assemble at site, even if the site is at a mountain top or anywhere difficult locations. It makes much more easier. Each blade panel assembly absolute angle with respect to the pivot arm can change up to 270 degrees in one rotation, every rotation, which is a very differing way of compared to the pitch change for the blades, which is common for all the 3 blades in the existing design. The design control system has inherent fail-safe features as primary and secondary control arrangements, individually capable of making invention to perform even in the worst case. So there are 2 controls. One is at the cam level in this design, and another one is at the blade level. So there are fail-safe arrangements possible, which is able to make it much more suitable. So advantages are super high output per square meter of wind area. It can give 5 to 10 times more wind energy for the same area swept. Effective energy generation starts at lower wind speeds, even less than 5 km/h, so that we can plan it out for a lower range and then keep it on generating for much higher range. So the ratio of energy generation to the cost would be almost double as compared to the present levels. Inherent protection against cyclonic wind speed. So we don't need any kind of stalling or braking or any of those things. It can withstand up to 200 miles per hour turbulence or the cyclones, and even during cyclone it can generate full power of energy, which is quite unimaginable. So that when you have a storm, you need electrical energy, and this will not stop you feeding energy. Turbine design is very lightweight and smaller components. On-site fabrication is very much possible. Employ parts of easily manageable dimension, even for super high power large turbines. Now, you have seen that in the present airfoil design, the actual air coming in contact with the blade is less than 10%. In most cases, it is 5% or so, which is actually contributing to all the power it is being generated. However, in case of our design, the 100% air will come in touch with the blade to generate electricity. So you can imagine how many times, multiple times, or even to unimaginable number of times energy can be drawn from the same area. In continuation to the advantages, material transportation to difficult sites especially is very easier. Maintenance will be much more easier, as there is not a single huge blade to be looked after, or the mounting arrangements for that to be looked after, or the shaft has to have all that kind of a shaft may still have to have all that kind of a weight, but if it is balanced on both the sides, it will be much more easier to manipulate. Again, mentioning about the no need of braking and self-protective design. Energy harvesting can be multiple purposes, multiple times, and vertical design includes direct mechanical drive at the ground. So if we have other than electrical purposes from the wind to be served, it can be very easily combined with the electrical energy generation. Better average kilowatt hour generated by invented process is certainly guaranteed because we are having a much larger wind range to produce optimum energy. So if the limit would be mostly by the generator and the mechanical infrastructure matched together, and mechanical infrastructure does not have to be stronger enough to withstand 10 times the optimum air pressure, because extra air would be released through the blades.
Sir, can I request you, because, sir, can I request you, we have reached 1410.
Pardon?
Can I request you, we have reached 1410 in time with respect to time, 14 hours, 10 minutes, that's
I will
16 hours,
just
10 minutes.
quickly finish it up.
Yes, yes.
So this is I have tried to explain horizontal and vertical axis. What are the advantages and disadvantages? So in both of them, and both have their own unique advantages and disadvantages, which can be imagined by even all those who wind experts. Now, technology-wise, it is again, I have explained all of these. I have tried to sum up the points, and here we need not go again into this. Only one thing is that there is no upper wind speed limit for operation in my design. Now, commercial-wise, we have less than 3 years of ROI for the projects because of the 10 times or more power generated and half the cost. And we have, this is all I have already mentioned. Planning and erection becomes much more easier. Potential.
Right, sir. Thanks. I have one question. One curiosity comes to my mind. Now, the concept is great. Now, when has this concept been tried on ground anywhere in India or somewhere?
Yes, I have done is a small wind tunnel test with a single panel, so that the drag and drift can be converted. Drag can be converted into lift in the reverse direction. That has been already proven in my labs, and I am going through a wind tunnel design of a 1 kilowatt actual generator as a prototype, which is under process, and it will be ready in another few months, where actual measurements can be done and documented and proven, given to the industry.
And have you also applied for any certification through NIVEA or somewhere? Because for small wind turbines, there is also a new process for testing.
I have only received this patent about 3 or 4 months ago.
Okay.
And now I'm working on all those possible things, because I am already working on another electronic communication patent through which PMO has already acknowledged, and they are looking after it. And I am giving them a demonstration on 29th. So these two are running parallel. So it's for my age, it is something too much. So it may take me some more time. But we are working on both of them, and we are putting everything in place. And as all the research has been done on my own individual's funds, and we have not taken any funds from anywhere, so it's a bit slow. And we are now we have approached your forum for international community to join, and technology is available. It is patented, so I can certainly offer it to them.
Thank you, sir. Now what happened? So through this forum, you could present this technology to a large international audience. There are a large number of people coming from around 13 countries. So you will get some inquiries from them, I guess. But before the inquiries come, I'm sure that you are making some program for making the test of the turbine on ground, apart from the tunnel testing. So wish you all the best. Though it was my pleasure. I took that liberty of, because as a moderator I have the speaking voice. So I just took the liberty of asking you the question at the moment beginning. But I now leave the session open for discussion, or any one or two questions quickly, either from audience or the other panelists. Yeah, Kumar, please go ahead. Your voice is not coming. You are unmute.
Yeah. Rakesh ji, first of all, thank you for presenting your innovation to the August gathering here. It is enlightening, and the way how you have combined the lift and drag forces together is a nice thought process as it is. A fundamental thought, but a nice one. So we are able to harvest better power by combining these two forces. And so as Prasad sir was mentioning, I'm curious to see how it practically works. If you have some practical setup, or if you're planning to set up somewhere, then I will be happy to come and visit. Few years back, I have seen a similar kind of apparatus or an equipment from an Australian designer. So he also made something similar, but maybe yours is slightly not slightly, yours is superior. But the shape and the shape of the rotor, everything looks similar. So I was able to connect immediately with that design. So I'm very much interested to see your design on ground.
That's I am open to it because it's now. See, I can't keep it enclosed within my boundaries. I need to percolate it to the whole world for the benefit of the whole world.
Yeah.
This technology can certainly make fossil fuels a thing of the past.
Right.
This
So
is my belief.
where are you located, sir? You are in North India, Delhi, somewhere?
We are located in Delhi and
Okay.
South Delhi in Okhla.
Okay.
Oh,
There is our factory, and my office is in opposite Apollo Hospital. So
then what we will do, we will coordinate with you and come and visit as and when, as soon as possible.
So if you would
We can
share
have more discussions.
if you will share the contact details of all the participants, then I would be grateful to you so that I can.
Definitely, yes. We will do that.
I can share with them at least, because I know all the panelists or all the people connected with your organization are the right people.
Yes, sir. Now
Right.
let us give time for any audience if they have any question. Otherwise, we are now 4:15, so we will close the session at the moment. We are running late we have started 15 minutes late, but now we are okay running late by 15 minutes. Daniel, do you have a question to him?
Yeah, I can maybe catch him offline, but I was just going to ask if he thinks the turbine's got a place in offshore wind, just around that concept.
Right.
It can work in any of the environments, because offshore would be equally good, because we will have our tower will have lesser drag on it, so it would be more suitable for offshore also.
But yeah, I'll contact you separately. I've got some other questions, but quite specific.
Thank you all the panelists. We have so the number is we have excellent breadth of the panelists. We have different technologies, both offshore and roadmap for the next developments by Kumar Vail, and
Yes, sir.
particular innovation. It's a good session as far as I can see, coming from the wind background. And what I also would like to thank SDI, Scottish Development International, for supporting this session particularly. And I think if all of you agree, we thank all the panelists with a clap. And we thank all the panelists with a clap. And then, am I visible to you?
Yes.
Yes, sir. Yeah, visible, sir.
Yeah. So we will thank all the panelists with a clap, and then we will be. This is a small world. Win the people, and then we are a small world people. We will get in touch with each one of them for our own interest and to take these technologies further into the world. Thank you all.
Thank you, sir.
Thanks, sir.
Right.
Thanks for
Thanks
giving
for
us
the
an opportunity.
Yeah. Thank you, sir. Bye.
It's our pleasure. Thanks.
Bye.
Right. So we will catch up again later.
Okay.
I am now closing this session.
Thank you, sir.
Thank you.